Hello everyone, welcome to Electric Vehicle Laboratory, Nitte Meenakshi Institute of Technology, Nitte deemed to be University. Today I am going to discuss about the battery management system with microcontroller. This setup helps to understand the charging, discharging and cell balancing process in the battery management system using a microcontroller. Here in this kit we are having inbuilt DC power supply, that is 24 volt for charging the battery pack, and here we are having a digital voltmeter, digital emitter and key switches for selection for different modes, microcontroller and cell multiplexer. Here we are going to see the different individual cell voltage can be monitored here, and we have FET bypass cell balancer, field effect transistor bypass we have. Then here we are having the 24 volt BLDC motor and one battery pack with the maximum voltage as 25.2 volt. Here we are using 1865O lithium ion cells, where each cell voltage is 3.7 volt nominal. Whenever we are going to charge this cell to 100%, the voltage will become 4.2. Okay, nominal voltage, battery pack voltage will be 22.2 volt, maximum voltage will be 25.2 volt. For discharging this battery pack, we are going to use this BLDC motor as a load. Thereby we are going to see or monitor the voltage and current of this battery pack. Now here the BMS regulates charging and discharging process to enhance battery life and prevent the overcharging, deep discharge and also the thermal runaway. Okay, where the procedure include connecting the battery pack to the microcontroller based BMS, and we are monitoring the real-time voltage and current values while we are doing the charging connection, as well as in the discharge connection the battery will be discharged by the BLDC motor, where we are going to record the cell behavior. 3. Now here first we do the charging connection. Here we are having the 24 volt DC supply for charging. First I am going to connect our digital voltmeter across the 24 volt DC supply and one to the inline with the ammeter, and negative I am going to connect across the voltmeter one and one more with the negative of the battery pack. Then another end of the emitter will be connected to the battery pack. Okay, then here this battery pack of 25.2 volt battery pack we are going to connect here with the 8 pin socket. Okay, after doing this charging connection and connecting the battery pack, we are going to turn on the mains and the MCB. Okay, after turning on, it will show the total voltage which is given from the supply, it's 24 volt, and DC emitter is showing the value as minus 0.07 volt, where the emitter will shows the minus 0.07 ampere, because our all batteries are battery cells are new, and the voltage we can see the total pack voltage is 23.78 volt, internal temperature is 26.29. Okay, and here you can see B1 to B6, it's nothing but the single cell voltage. Okay, now for charging purpose we need to get the pack voltage. For the 100% charge it has to reach to the 25.2 volts. here we can see the measurement unit keys. Okay, OK or enter, upside button, downside button, and return button. Okay, whenever I am going to press this OK button, it will show me auto cell balance, even cell balance, odd cell balance, and cell balance off. Okay, now it's blinking here at the auto cell balance. I'm going to press OK. Okay, it will showing me that it is balancing cell 2. It is asking me balancing cell 2. Okay, that runtime means already it's start balancing automatically. Initial voltage is 4.04. Okay, like that, if I press this, I'll OK. Now after pressing OK, it will show me balancing is complete. Current cell voltage is 4.04, initial is 4.04. Okay, for just for the example, I have shown that one how this auto cell balancing will work. Then if I'm going to press the even cell balancing, I need to press this downside. Okay, now it's blinking at the even cell balancing, so I need to click OK. So what will happen? It will balance only the even cells. Here we can see, okay, VC2 LED indicator, VC4 LED indicator, VC6 LED indicator. So runtime also it's going to show here. Now I am going to press OK. Okay, now for that odd cell balancing, similar method we are going to use. Okay, now we can see here VC1, VC3, VC5. Okay, it is balancing cell 1, cell 3 and cell 5 in the odd cell balancing. Fine. Now coming to cell balancing off, I am going to press OK and the cell balancing automatically it will off. Okay, now here you can see the cell multiplexer. Okay, it is reading the internal temperature, then it will come to VC1, VC2, then VC3, then VC4, then VC5, then VC6. So the microcontroller inside, what it will do, it will continuously monitor the voltage of cell 1, cell 2, cell 3, cell 4, cell 5, cell 6 and total temperature of the battery pack. Now this is what about the charging and balancing the cell. There we have seen auto cell balance, even cell balance and odd cell balance. Okay, now coming to the discharge, there is a small correction we need to do in the discharging connection. Before that I need to turn off this MCB. Okay, I am just going to connect here.
Starts.
Now this supply voltage I don't need in the discharge because I am going to discharge this battery pack, so that I am directly connecting this to the motor. The supply to the motor is given from the battery pack. Okay, now we are having this connection. First we need to do this one with the motor output. Here we can see motor input is from the battery, motor input is from the battery and motor output is connected to the 24 volt BLDC motor, and this connection we need to make with this motor. Okay, before we need to check this knob or a POT has to in the minimal position. POT is nothing but the potentiometer.
3.
Okay, now before turning on the MCB, first we need to check all the connection. Okay, battery output is connected to the motor input and motor output RYB is connected, as well as this Hall sensor connection is connected, so that now the connection is perfect, so that I will turn on the MCB now. So here you will see the reading of digital ammeter as 0. So here we are using 24 volt BLDC motor as a load. Okay, load is nothing but the current drawing element, so that this motor has to draw the current from this battery pack. Thereby we are going to see the real time values or parameters of voltage and current. Now I am going to increase the speed using this POT. By
starts.
now here I am going to increase this POT. Okay, now this 24 volt BLDC motor will draw maximum of 0.5 ampere or 0.48 ampere. So you can see okay. Now before that, what we are going to do here, first we need to see the initial single cell voltages. Okay, whenever this is in the discharge mode, now we are going to note down the 24 volt and this ammeter values, and as well as B1 to B6 values and pack voltage. Okay, and internal temperature and external temperature. So in the tabular column, for different speed of this motor, we are going to note down the total pack voltage, as well as we will get to know that whenever this motor is continuously running for some time, then automatically the pack voltage will reduce. Pack voltage is reducing in the sense inside a cell voltage is also reducing. Okay, whenever we are getting any battery pack, we cannot know how the single cell is performing or how that is supplying the current, but from this we can see the single cell B1 to B6 voltages as well. So this setups regulates charging and discharging process of a battery pack with the BLDC motor, as well as it will regulates the battery lifespan and efficiency by regulating the charging and discharging process of the battery, and also it will balance the each cell in the battery bank. Here we have the option for auto balancing, active balancing and odd balancing. Overall, this microcontroller based BMS will enhance the battery life, as well as which will prevent the overcharging and deep discharging and also the thermal runaway. Thank you.